All right. Hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today. My name is Sarah Oswald. I will be your webinar host, and I am coming to you live from Cincinnati, Ohio, here in the U.S. As you may know, Siemens is a very global company. We always have people joining from all over the world, so we'd love to hear where you're joining from today. You should see the attendee chat widget on the left-hand side of your screen. Feel free to pop in there, say hello, and let us know what part of the world you're joining from. Also, before we begin, we'd love to know what's bringing you to this webinar today. You should see a poll that just popped up on your screen. If you don't mind, go ahead, take a moment, let us know what brings you to our webinar. And welcome to those of you just joining. We'd love to know where you're joining from, so feel free to say hello in the attendee chat and let us know your location. Also, if you don't mind, take a moment, let us know what brings you to this webinar today. Cleveland, Ohio, welcome. Gainesville, Florida, hello. All right, I'll leave the poll open for another 10, 15 seconds or so. Germany, welcome. UK, hello. Hello, hello. All right, so thanks to those of you, another Germany, Munich, welcome. Thanks to those of you who took a moment to respond to our poll. And again, you can keep saying hello in the chat. Let us know where you're joining from. Dallas, Texas, welcome. All right, so I do have a few housekeeping items before we get started. All right, let's see here. So I think everyone probably already found the attendee chat. I just am going to call your attention to a couple other widgets here. At the bottom of your browser in the center of your screen, you'll see the widget dock, and these are the interactive tools you can use throughout the webinar. You can minimize, maximize, and scale each one to customize your viewing experience on your screen. I would also like to call your attention to the Q&A Ask Questions widget that is open and on the right-hand side of your screen. Feel free to submit your questions for the presenter at any time into that widget throughout the webinar. It will look like your question disappears after you submit it, but don't worry, I'll still see it just fine, and we'll save those for the Q&A. You might also get a typed response during the webinar, so go ahead and put those questions in at any time. And if we don't get to your question at any point in time during the webinar, we will follow up with you offline. So no question will go unanswered, so definitely type in any questions you may have there. I'd also like to call your attention to the help widget. If you have any difficulties with the platform, feel free to click on that. You can also message me in the chat or the Q&A. But do know a quick refresh of your browser here and ON24 will solve most technical issues, so definitely give that a try. Also, this presentation is being recorded, so you'll receive an email with a link to view the recording, and that is ready, so you can, of course, watch it again and then share that around as you see fit. And finally, we have some related resources for you. There you can find a PDF of the presentation and download that there. All right, a little bit about Siemens Digital Industries software. Siemens Digital Industries software helps organizations of all sizes digitally transform using software, hardware, and services from the Siemens Xcelerator business platform. Siemens software and the comprehensive digital twin enable companies to optimize their design, engineering, and manufacturing processes to turn today's ideas into the sustainable products of the future. From chips to entire systems, from product to process across all industries, Siemens Digital Industries software accelerates transformation. And one more quick thing before we jump into our presentation today. I just want to make everyone aware of Realize Live, an event we have going on all over the world. Essentially, you can see here Nevada, Germany, and Shanghai. So hopefully there's a location that you'll be able to get to and attend. You can go to realizelive.com to get more information about that, and we hope you can join us. All right, well, our presenter today is Chad Hawley. You can read more about his bio in the bios widget on the left-hand side of your screen. You can just click the little blue arrow to read more at any time. I don't want to take any more time from his presentation, so I will go ahead and turn things over. And again, I will see you all during the Q&A. All right, thanks for joining us. Here we go.
Hello everyone, and welcome to today's webinar. Have you ever heard of saying a building is only as good as its foundation? It's an old analogy, but still good when you're considering implementation of a new process. Having a good foundation is not only good in architecture, it's key for any business practice, especially when going through change. Change is hard, and people don't like it. There's normally stubborn organizational momentum to overcome, but most companies mandate continuous improvement, and in order to do that, they must manage change. If you're part of that change process, and you want to look good during this difficult transformation and avoid the internal resistance to change, you must have small wins along the way and build trust with your design community. How do you do that? By being strategic and practical in your deployment, having a good plan, and leveraging the expertise of those who've done it before. That's why today, we're going to talk about how you make the electrical design journey using the generative properties of Capital. Why should you listen to me? My name is Chad Holly. Currently, I'm a product manager in the connectivity domain for Capital. Specifically, I'm responsible for our logic designer and wiring integrator applications. In the last 20 years of my career, I've transitioned through most phases of responsibility with Capital. From being a designer to resident expert, then to software deployment lead, and finally making the jump to work directly for Siemens, I've supported many different companies across automotive, off-road, military, and aerospace in their deployment journeys. Each had their own vision for what their ultimate electrical design goals were, and each had unique challenges. One of the reasons I've seen customers choosing Capital is because of our unique platform generative offerings. But as you'll see today, there are generative design principles built into all of our applications and out-of-the-box process flows. So what is generative design? Well, I did a quick Google search and it gave me this definition. It's an iterative design process involving software that will generate a certain number of outputs meeting specified constraints. The generative methodology can be applied in many design spaces like 3D mechanical, printed circuit board, and even code generation. And currently, there are several factors driving the need for generative design. Across the board, companies are seeing enormous pressure to reduce costs and development time. Electrification across industries has exploded, and with that added large amounts of complexity that is getting more and more difficult for a human to design, let alone optimize. We're seeing more autonomous vehicles. Those come with mandates for compliance and first-time quality. And finally, globalization has introduced huge challenges for standardized design practices. Generative principles are very good at addressing all of these challenges. One of our partners who is currently on this journey is Airbus. We have been engaged to help guide them on their deployment plan and to give them some small wins along the way as they transition their design methodology to include more generative functionality. One of the methods they employ is the application of standardized and automated DRCs, and they are already starting to see the results with faster development times, better first-time quality, and a more seamless transaction with their suppliers. So we've talked generally about generative design, but I'd like to target generative in electrical. What tools or functionality do you know of that use generative principles for wiring design? Take a second to think about what you have experience with. Applying generative principles to your electrical workflow provides the well-known benefits of standardization, efficiency, repeatability, and quality. This is achieved through the capture of your internal best practices and IP in a hard-coded set of rules and constraints, and then using them to create an automated and desired wiring result. This graphic is a high-level view of Capital's full-blown generative design flow for electrical, and it provides a good description of how it works. On the left, we have our inputs, and the two major ones are the logical designs and the platform topology. Contributing to those could be carryover designs, option or variant codes, the product plans defining option, variants, and build configurations, requirements, and ICDs. In the middle is where the magic happens. This is where your company IP is captured in the form of rules and constraints, and the platform harness topology is laid out. This is also where the next level of automation occurs and what most people think of when you mention generative and Capital. Another powerful add-on at this level is the ability to apply metrics to your design and perform quick trade-off studies. These metrics are baked into Capital and allow you to do real-time analysis on the effects and cost of change. On the far right are the generated outputs in the form of wiring and harness designs, service documentation, and validation artifacts. Let me give you an example of what this means in the real world. I've witnessed firsthand an example of the benefits of generative design, and that was when I was supporting GM. Let me tell you about it. Engineering was very close to the release of a completely revamped car platform when marketing decided that they wanted to sell to the European market. Unfortunately, a right-hand drive configuration had not even been considered. Now, in the past, a major variant such as this would have taken a year or more of engineering effort, but because the platform architect was using generative design, he was able to place the variant components in the platform topology and generate the new wiring configurations automatically. What traditionally would have taken many months of effort only required a couple of weeks, with the added benefit of keeping the originally planned release deadlines. That was not only a huge win for our customer, but also proof of the enormous value of generative design. Gulfstream is another example of a company who has leveraged generative design. They've been very successful with using generative automation to produce their electrical service documentation. This has given them significant time savings and a huge competitive edge in their industry. They've also applied these principles to manage and apply engineering changes across all of their design effectivities, cutting engineering change management time in half. I've discussed this fully automated generative flow, but how do you get there? Some companies don't want that full automation or want a simpler flow. Or maybe as an organization, you want a midpoint between manual and fully automated processes. This is similar to how we all approach education. All of us have some experience with the education system, and it's safe to say we've all been to high school. And there are many opportunities out there for someone with a high school diploma. The next step up is a college diploma. This requires more effort and resources, but there are more opportunities. Finally, with much more effort and money, you can achieve a graduate degree, and with that have access to more prestigious and higher paying jobs. This analogy helps answer the question of where do you start. Just like school, you don't dive into graduate classes. You look at where you're at first to see what adoption phase is appropriate for your organization. Capital allows for that phased growth. We have clearly defined out-of-the-box process stops that can align to a current workflow or enhance it. It starts at a more manual interactive design and allows you to progress to more and more generative automation. And like school, your organization should pick a process stop that fits your needs best. The nice thing about Capital is that all stops are good, each has value, and each has generative design principles. So what are the stops I've been talking about? We have 4 defined flows, and there may be more value in our most automated flows, but there's value in all of our offerings. First flow is interactive. It's very stable, easy to adopt, and it mimics most current workflows. Some of the high-level benefits of interactive are improved quality and consistency of data, ECO reduction, elimination of data reentry, improved workflow management, and the reduction of design and documentation time. Our next flow is Platform Interactive, and this brings in the harness topology abstraction to aid in wire routing and breakpoint definitions. It enables platform visualization, validation, and navigation of wiring data. And because the topology is drawn to scale and can be synchronized to your 3D model, you have the ability to calculate wire lengths and to back annotate to your wiring designs. It also allows for intelligent filtering of aircraft data, and an example of that is by effectivity. Our top level flow is Platform Generative. This is our premium offering, and it gives you things like automated wiring synthesis based on harness topology, rules, constraints, and product packaging. Also, platform level effectivity wiring, quick trade-off studies and optimization, reuse of global systems designs, and early bundle diameter calculations. And our final flow stop is First Pass Platform Generative. It's a hybrid of our generative and interactive flows. This gives you all of the upfront benefits of generative, automatically generating 80 to 90% of your wiring solution with the flexibility to manually finish some of your wiring corner cases that don't conform with the standard constraints or rules. Wiring is then sustained using the Platform Interactive flow. So let's now take a look at some demonstrations of these 4 flows, starting with interactive. Interactive is a more manual methodology, but Capital provides for generative principles even in this flow. So let's start the video. So what I'm going to do here is I'm going to add a laser controller device from my ICD. Look at it, I'll place it there. And now I'm going to add the connected component, and you're going to see some generative properties right away. Since these are 2 ICDs that are defined, the wiring is automatically generated between them. And now I need to add some breakpoints. So I'll select an inline, add it to my wiring, and you'll notice that it automatically bisects the wires and ensures that the pinouts are kept aligned. So I'll add one more. There. And now I'm going to add some connectivity to some existing wiring. And I see a splice sitting there. I'll select that, add it to an existing wire in my new diagram, and you'll see an automatic splice has been added. And the last thing I need to do is add the harness properties or attributes to my wires. And I'll do that manually by selecting the wires, going to the properties, and then adding the harness attribute manually. And that sums up interactive flow. Platform Interactive is next, and it adds the platform harness topology. Let's see how that works. You'll see that I start just as I did before by adding my devices with auto-generated wiring. You'll see the 2 devices I'm going to add quickly. But after I do that, this is where I stop and jump to the topology. Topology is going to help me route my wires. What I first do is select the wires I want to route and Routing Assistant. Routing Assistant highlights the path the wires need to take to connect the 2 devices. So you'll see I'll zoom into the 2 devices, and then I can come back in, select the path, and commit it, the inline placement back to my wiring design. Let's go back and look at the wiring, and you'll see that all I did manually, including harness assignment, has been completed using automation. Now we're going to look at some platform generative demos, starting with the high-level flow. We have a topology like before, and our logic designs. These are a bit different because they utilize nets rather than wires. Notice that there are no physical objects like connectors, inlines, or splices. These will be generated later. Going back to the topology, I want to show you some of the drivers for the automation. And we're going to start with the rules and constraints. So I'm going to open the properties for my diagram, my design here. And so these are the rules and constraints, and they drive how your wiring will be generated and allow you to capture your best practices like max wires on a splice or splice separation. And next we're going to look at another driver that manages option complexity. We do this through our product plans, and let's open that up now. So these plans contain the major models and allow you to define what major variants and options are applicable to each model. The automation will generate wiring solutions for each of these defined models. And next we have all the nets associated to this plane, and they're contained in 10 specific revisions of logic designs that we manage with the build list. Those are listed there. And now let's synthesize the wiring. So in real time, the automation is generating the wiring solution for each net and each option and variant for the specified models. So you can see it goes pretty quickly. If I select one of these nets, you can see the highlighted path. So let's pick one. This power one looks good, and you'll see on the right that the path is highlighted. And then I can visualize that wiring solution. Let's see, that pops up on the bottom. So that lets me validate that I got the wiring I intended. And then once I've fixed everything up the way I want, I can generate full wiring diagrams automatically. The output can be configured based on your needs and also filtered based on vehicle models or some custom configuration. So here are some of the options, and here's some of the filtering functionality you have. The other thing we have is the ability to use a prototype. If I had some other diagrams that I'd manually laid out, I can use that as a guide to lay out the new diagrams. So let's take a look at what those look like. Again, I'm going to go into the audio system. You can see it looks quite different. So now I have connectors on all my devices. I have wires instead of nets. I have grounds and splices. All that was generated automatically through synthesis and the rules that were on my plane. And just look back at the nets to see how different it is. A very simplistic point-to-point connectivity that gives you, in conjunction with the topology, a full wiring solution. This next demo shows you how generative design makes trade-off studies quick and easy. So I want to move the CD changer from the trunk or boot to my IP harness. And it's really easy to do that. I'm just simply delete the bundle connecting the CD changer, like so. I select it, and I just drag and drop it to the new location. And I'm going to put it right here. Then I simply connect a new bundle to the connector of that device or slot, and I run synthesis. And my wiring is generated. Now I have a tool within Capital called Capital Insight, where I can look at the effects of moving that. So you can see the red and blue dots for all my wiring here is showing the cost impact, but let's look at the cost of the material itself. So I've got 3 different types of wire, and you can see the TWC cost went down. And let's look at the effects on the actual harnesses themselves. You can see the body harness, since I moved it out of there, the cost went down, but it did go up in my IP harness, and I can look at the actual numbers by hovering over the data point. So I can make several of these changes and look at the effects very quickly, so I can optimize my design efficiently. This final demo shows the power of reuse in generative design. So many customers have common subsystem designs, but different physical implementations. Generative design enables the easy reuse of those common designs. So in this use case, I have a sedan and a coupe with different harness layouts and component placements, but I'm able to use the exact same logical connectivity for each, since my physical wiring implementation is generated. So you can see those were the logicals that I've associated with the sedan. And now looking at the coupe, you can see my layout's quite a bit different. I've got an inline here in the middle. On the other side of the vehicle, my CD changer is on the IP harness. So just take a look at the differences here. There's the PDB on the sedan. Inline here. But if I come in, I can associate the exact same logical design. See, this is the same build list I'm associating to it. So let's then run synthesis. I'm going to generate my wiring for the coupe, and we're going to take a look at some of the differences using the exact same logical designs. And we looked at a power signal before. Let's check that same power signal. If I click on it, it highlights the route. You can see it's quite a bit different than sedan. Let's look at the sedan route. And it's different. It's on the other side of the vehicle. And we can take a look at the detailed differences between the two. So we'll visualize that signal, and you can see the wire goes through actually 3 harnesses. So there's 2 inlines it goes through. And on the sedan, if we visualize that, it only goes through 1 inline. So same logical designs, different physical implementations. The last flow is our first pass platform generative. And it's a hybrid flow that uses platform generative to generate 80% or more of the wiring solution, and then utilizes interactive flow to manually modify the generated wiring diagrams. And that's for specific use cases or corner cases that the automation didn't fully realize. So let's look at the demo. So again, I start with platform generative. It generates most of my wiring, and then I use our AutoView technology to generate all the diagrams that were in the plane. And in this use case, I want to go and use double termination to my ground connectors. So these are some of the ground solutions. I'm going to come in, and some of the power as well. I'm going to delete the splice. I'm going to double terminate to the connectors. You can see it's easy to do that. I did that for my power, and then I'm going to come down here for my grounds. Again, I'm going to delete some of the wiring to my splices, delete the splices as well, and double terminate to the grounds. And I've got one more to do. Delete the wire. Delete the splice, drag and drop, and then I need to connect these as well, so I'll add a wire between the 2 grounds. And I'm done. We discussed the different levels of schooling and the stops along the way, like high school, college, and graduate school, and how that relates to the flows in capital. You need to choose the best fit for your organization, but with capital, all of these stops are good, all have value, and each one employs generative design principles. I also asked you to think about what generative functionality you knew about for electrical design, and we went over how we have applied these principles to capital. And finally, we started off with knowing the importance of a good foundation and how a good plan and key wins can build support in your organization and make you look good. It's important in your journey to be realistic about where you are currently at. How organizationally mature are you, and where do you want to end up? All of that plays a big part in the success of your generative journey. Thanks for listening in. Now I'll move on to some questions.
Right. So thank you so much for your presentation, Chad. We do have time to answer a few questions here. Attendees, I would like to invite you to please keep typing your questions into the Q&A Ask Questions widget. It should be located on the left-hand side of your screen. It will look like your question disappears, but we'll still see it just fine. We'll get to as many of these as possible. If we don't get to your question, we can follow up with you offline. All right, Chad, let's see here. Our first question. You mentioned how Airbus is using automated DRCs. Could you explain in a bit more detail how that works in Capital?
Sure. I think the best way to do that is to give you an example scenario. So in all capital applications, customers have the ability to create different release levels for their designs, and they can then define the transition behaviors of those releases. So one of those automated behaviors is the action of running configurable design rule checks. So for instance, they can set up a release behavior to run a set of when they transition from like a draft release to some pre-release state. And then they can set the checks to be at a certain level of severity. And then for subsequent releases, the severity of those checks can gradually get more and more severe until all the checks must pass for like their final production release.
Okay, great. Thank you. All right. For the platform, generative flow, what did you mean by reuse of global systems design?
Okay, so I did demonstrate the reuse of system logic designs in one of the demos, but I've worked with customers that standardize and mandate the use of these global designs. And that's kind of what the global system designs are. So with platform generative, these point-to-point system designs can be directly reused for every platform. And because the physical wiring solution is generated at the platform level, that allows for that reuse.
All right, and I want to get to at least one more here. Again, attendees, you can type those questions into the Q&A Ask Questions widget. All right, in the interactive demo, you showed placement of predefined devices and automated connectivity between them. Do I need to build models for devices before I can place them in the diagram?
The short answer is no. What I was doing in the interactive flow was showing the most automated feature of interactive flow. But in Capital, we have what's called the parameterized device. We have that for connectors, wires, and nets as well. And these can be drawn on the fly with absolutely no setup. So unlike some other electrical design tools, this really provides a ton of flexibility to customers to start capturing connectivity right out of the box with no setup. So as a customer grows, then these objects can be associated with either library parts or ICDs.
All right. Well, thank you so much, Chad. I think that will conclude our Q&A. I do see a few thank yous coming through here, so I would like to pass those on behalf of our attendees, and I would like to also thank you for taking the time to present. So thank you so much, Chad.
Thank you.
And we would also like to thank our attendees for joining us. You will receive a follow-up email with a link to view the recording of today's session, so you can, of course, watch that again. And please do share that with your colleagues as you see fit. Everything will remain in this room, so if you need to come back at any time, you can come back in here and you can still submit questions through the Q&A widget after the webinar concludes. However, you can also just email me directly, sarah.alspaugh@siemens.com, and I can forward you or point you in the right direction. And if we did not get to your question today, like I said, we will follow up with you offline. A quick reminder about Realize Live before you go, please head over to realizelive.com to get your tickets, and we hope that you can join us at one of our events this year. If you have a project in mind or you would like to speak with somebody directly about more information, this QR code will take you to a list of phone numbers so you can choose the correct phone number for your location and get connected to someone today. This is also in our related resources, which will stay in the room, but you can bookmark that link before you go or come back and grab that at any time. All right, well, this concludes our webinar. Thanks again for joining us, everyone, and have a great rest of your day.